It's a great pleasure to be here today. We happen to be visiting India. I was in Delhi yesterday, in Bangalore today, Mumbai tomorrow. It's like, if it's Thursday, it must be Bangalore. And they asked us if I could step in and say a few words about innovation as we perceive it in engineering schools. So my talk will be innovation entrepreneurship, an indispensable pillar of engineering schools. And this talk actually is co-authored with my colleague here, Andrea Belch. Andrea, can you please stand up? She's entrepreneur in residence at USC, and she has brought at USC a significant expertise in innovation and entrepreneurship, and we are very happy to have her expertise in the school. What I will discuss today is a few things. First of all, the ability and the amazing times that we're living in, the explosion in technology, the exponential changes that we see happening, sometimes even more than exponential, how engineering schools particularly take advantage of this in order to shape the next big innovation, and particularly how to encourage entrepreneurship innovation, both at the undergraduate student level, as well as the graduate student level and research. I'm using here a quote from the late president of the National Academy of Engineering, Chuck Vest, who was the former president of MIT, who said that this is the most exciting era for science and engineering in human history. Let me repeat that. The most exciting era for science and engineering in human history. That's something, this is an unbelievable time that we're living in, and I think it's an era in which everyone in the world can participate and contribute, and I think this whole movement of startup companies that we see happening is actually a good example of taking advantage of that. Now, I am a professor as well, which means that I will show you two equations of mathematics here. Bear with me. I think that the technology evolves as a chemical reaction. Don't ask me why, but I think it does. And the way you look at the evolution of technology, if you think that it evolves by feedback on itself in a linear way, then essentially the rate of change of technology is proportional to the level of technology now. If you integrate this equation, I know some of you have no particular interest in integrating anymore, nonetheless you get an exponential dependence. And so you can see this is actually Moore's law. Moore's law is nothing else but simply the statement that technology grows in proportion to its level right now. So it doesn't have to be a specific Moore's law. That's why you see it in biotechnology, you see it in any other technologies as well, with different exponents perhaps. And so this exponential, it is this exponential technology rate that we see in front of our eyes that we need to take advantage and make use for benefit of humanity. Now, if you ask me the question, what about if the kinetics is second order, like this? In other words, technology is the collision of two technologies. This gives rise to a new technology. Well, if you do this integration, again, don't try it at home, you will find that actually technology grows faster than exponential and actually may approach a singularity. There's a noted visionary by the name of Ray Kurzweil, who is now the chief engineer at Google, who believes that we're approaching a singularity because the technology goes a lot faster than simply exponentially, and that's a cartoon on how fast it's going. Whether you believe the first or the second, whether you believe Moore's law will continue or not, the key point here is that we are living in an era in which things happen extremely fast, and that's why we have this phenomenal ability in front of our eyes and in our hands to be able to make a significant discoveries and development of new things that we have never even imagined before. And the IoT is actually one example of this spectacular growth. Now, I use a different definition of technology than most of you, and here's my definition. Oh, I'm sorry. If you look at I will get back to that in a moment. If you look at technology, you consider exponential technologies that require, let's say, significant advances at the research level. It requires a very in-depth understanding, like biology and computer science and the like. And so this is like exponential technologies. You have a lot of digital technologies. You see this all the time in the area of apps and so on and so forth, where digitization is what drives many new developments. And that's an emphasis where essentially is computer science is or digitization is a new language to interpreting even experiencing our physical world. And the third type of technologies are combinatorial technologies, in which you see a lot of this happening, particularly at the undergraduate level, where students pick up a little bit of this, a little bit of that, put them together, they have an interesting idea, they have a package, and then throw it out. And this is, of course, something that was pointed out by Olson and McAfee book, The Second Machine Age, which I recommend very highly. It was a book published last year. It's a wonderful book to read to understand the digital age that we're living in. Now, I use a different definition of technology than most, and I call technology exploiting a phenomenon for useful purposes. So for me, technology is not simply devices, it's not equation, it's not digital things, it is really exploiting phenomena for useful purposes. And in degree of increasing complexity, in the past, were physical phenomena driving most of technology, then more chemical. Now we see a lot more biological phenomena driving technology and the convergence with the medicine. And I believe that not too far into the future, we will also be dealing a lot with social phenomena. We see it already in the social media world, but I think social phenomena will become part of what engineers do in some way in the future, in a way that it is very different than it's done today. And I think that's another very exciting possibility for engineering and computer science. When I look at what we do in an engineering school, we do the following three things. We look for talent, and that's something that you do in any company, in any organization. Talent, whether it is faculty or students, and how to make sure this talent is flourishes, and so you provide the culture for them to be successful. The second thing we do is we try to continuously add value. We have to give new programs, new infrastructure, new developments to make sure that whatever the students and the faculty we have in an engineering school benefit from yet more and better things that are available to them. In engineering schools particularly, we solve big problems and create opportunities. So global leadership and thought leadership is very important. However, there is a fourth pillar, and that's the pillar I want to talk to you about today, which is innovation and entrepreneurship. Because engineering schools don't only do the first three things, attracting talent, adding value, and solving problems. You also have to make sure that these problems that you try to solve have impact. And this impact happens only through innovation and entrepreneurship. So I believe that innovation, entrepreneurship, relevance, consequence, and impact is fundamental to the mission of engineering schools in today's world. So in these four pillars, I try to encapsulate what we do in an engineering school. The rest of my talk will focus specifically on innovation and entrepreneurship. So how many of you know which part of the United States graduates the most engineering and computer scientists in the country? And the answer is Southern California. It is not the Bay Area, it's not the area, it's not Boston area, it's not Maryland, it's not Georgia Tech, it's Southern California. So that's a good commercial for Southern California. It generates the largest number of engineering and computer science graduates. And it is something now which is called Silicon Beach in parallel with Silicon Valley over here. This is an emerging ecosystem that is very strong and actually is considered right now is ranked number 3 in the world in terms of the ability of new startups and in attracting venture capital. We at the University of Southern California actually are located right in the middle of that ecosystem, and the type of things that we try to do at UAC Viterbi are things that relate to incubation. For example, we have a student innovation institute and a Viterbi startup garage. That's an incubator that helps to inspire and also get companies out. We do teach, for example, in a partnership between the health, technology, and engineering and the USC Calder Foundation. This is an activity that we do by partnering medical doctors and engineering students. We do competitions, which are, in essence, different versions of an incubator, the Machine Entrepreneurship Prize Competition, MEPC, which provides an environment for companies that have that come in with a certain idea to be able to bring them towards the next level. And we try to change culture as well through the existence of an NSF I-Core node. This is the National Science Foundation has awarded to USC a node of activity in which we try to change the culture within the universities, not only at USC, but across Southern California, in terms of getting people who do research, like faculty and graduate students, to understand that it is very important that as they conduct their research, they have an eye towards innovation. And that's something that we'll talk about in a moment as well. So we teach, we inspire, we incubate, we compete, and we try to change culture. And a very recent gift that we received actually from one of our donors is to not only do competition for a pure entrepreneurship, but as well for social entrepreneurship as well. And that's an activity that is going on more and more in the United States, where many students are not only interested in startup companies, but startup companies with a social entrepreneurship component towards social venture, and that's something that we are trying to push aggressively as well. So our mission is to teach, think, launch, and link. So teaching at the undergraduate and graduate curriculum, and also in extracurricular continuing education or postdocs. Think, how do you think as an entrepreneur in terms of research and a practitioner? Launch, creating companies, and also supporting the industry, and link between universities, innovators, and capital. Now, I want to say a few things about Silicon Beach. And this is Southern California. This is actually Los Angeles. USC is located near downtown Los Angeles, but it has also presence within the bay, the coast, the beach, if you like, which is the ISI, the Information Science Institute. I know that ISI is a bad word here in India, but ISI means Information Science Institute. Actually, it's headed by an Indian fellow, Prem Natarajan, who is actually a wonderful new director of ISI, not in Pakistan, but here. And ICT is the Institute of Creative Technologies. So this triangle over here is dominated by USC. And you have all the major companies from the Bay Area have now migrated down here. You have Yahoo, Google, SpaceX, Microsoft, Facebook, Google, and the like. And this is our incubator at the Viterbi Startup Garage. Northrop Grumman is here. And in any event, Caltech is over here, which is in the Pasadena area, and UCLA is over here. So in some sense, what we have in Southern California is the equivalent of the Bay Area, where the role of, let's say, the Berkeley is played by UCLA, the role of USC or the role of Stanford is played by USC. So we have this particular aspiration to play in Silicon Beach the same role that Stanford plays in Silicon Valley. In fact, to go from silicon to silicon, which is SC meaning USC, silicon. And so that's really what we want to dominate this particular part of the ecosystem in Southern California. Let me give you a life cycle of the commercialization involving with undergraduate students. And student-led innovation, concept review, courses, competitions and mentoring, startup garage for customers, mentors, and then, of course, trying to get capital, press, and what we know as a real deal in which the companies that come out of there can acquire then the ability to raise additional capital. With respect to the life cycle for faculty-led innovation, and as you probably know, in innovation at the faculty level, mostly of this work is supported by the government. The government provides all the intellectual property to the universities for free. So the universities own the intellectual property, and the question is, how do you commercialize it? And so this is concept review. Again, competition. We have the I-Core program that I mentioned before to find customers, to be able to change culture, and then prototype in grant. And we have a number of activities that do that, which is a forum of mentors, a Stevens Center for Innovation at USC that licenses technology that is owned by the university. Again, incubators to grow a company, and again, the real deal to be able to move it and launch it out in a capital and press. So when I look at what we do within the Viterbi School of Engineering, we do try to inspire, educate, create, mentor, and launch. So this sequence of events, of activities, inspiring, educating, creating a company that is mentoring that company and launching it is something that we have been doing at USC for the last 5 years or so, when we realized that technology is at the core of any innovation. And many of the activities that I mentioned include an innovation institute, the I-Core program, the Viterbi Startup Garage and Incubator, competitions, the Alfred Mann Institute that actually incubates companies in the area of biomedical engineering, Stevens Center for Innovation, and the combination between health, technology, and engineering that I mentioned before. It's a partnership between the Keck School of Medicine and USC Viterbi. And finally, I will want to give you yet another sequence of steps in the Stevens Institute, which is part of USC commercialization. And again, the idea there is a disclosure of a company, preliminary review, how do you protect the intellectual property through IP, development of business, licensing if possible, commercial development, and then hopefully and ultimately a license income with a particular ongoing assessment of this process as it's going along. And so this is mostly applying actually to commercialization of intellectual property that is developed at the university and it's owned by the university. Challenges, we want to make sure that our students and our faculty understand, and through customer discovery and business models, what are the appropriate models to use. Engineering faculty and engineering students may not necessarily be the best trained for that, so we like to bring this new innovation and entrepreneurship culture into the school. How to make sure that the companies have the appropriate legal structure and legal support, and then ultimately support for capital and people. I mentioned the National Innovation Node from the National Science Foundation. The National Science Foundation, which is based in Washington, D.C., has sponsored 7 nodes in the nation. This is 1, 2, 3, 4, 5, 6. There is a 7th one that has come up since then, and which is this one. And this is at USC, and it's a center at the University of Southern California in partnership with Caltech and UCLA. And as I mentioned before, my colleague Andrea Belz is the director of this. The idea is to change culture about innovation and entrepreneurship in engineering schools, and our goal and our mandate is to spread actually this culture all over the area around Southern California, including the states of Arizona and New Mexico, Utah, Nevada, even north to Oregon and Washington, as well as to Hawaii. And that's our mandate, to be able to bring a way by which engineering should be and technology should be at the center of every innovation and entrepreneurship activity. Finally, I will close with my very quick thoughts on big data. IoT is ubiquitous and continuous in terms of sensing, computing, communicating, control, and actuation. You can even consider an organization, a human organization, as something that's subject to IoT, with the addition that in addition to the sensing, computing, and communicating, you can possibly add ideation as well. And I think that this is a much bigger concept that applies essentially to how you collect, compute, communicate, control, and actuate data. So there is a very, very big connection between IoT and big data. Of course, big issues are cybersecurity and privacy, and this have to be embedded from the very beginning as you form an IoT. In the area of big data, we have a big effort at USC to create degrees in informatics and big data, emphasizing 3 things: skills, which come usually from engineering and computer science, like machine learning, visualization, artificial intelligence, statistics; context and domain knowledge, which is asking the right questions. And you can have big data in areas like communication and journalism, or cinema, or business, or many different disciplines, health, medicine, informatics. And also, the final question is who owns the data, and therefore, again, the issues of privacy and security. So these type of degrees, actually, we are putting forward right now are informatics degrees that take a combination of skills and talent from the engineering school, along with asking the right questions which come from the context that can be from a different school. As I mentioned, could be communication, or could be social sciences, or could be biology and medicine. And the final question, of course, is issues of policy and law that include privacy and security. And I think there are huge innovation and education opportunities. In fact, my colleague Andrea Belz is working with Intel to create a course for IoT that will be available to many different partners in the United States, and that's something that we are very much interested in involving it. So that's all I had to say. I hope I did not exceed my time. Thank you very much, and appreciate if any questions.
Could you tell us a bit more about how you use the NSF network to foster your innovations? Can you give an example?
So your question is about how the NSF, the National Science Foundation...
Those 7 nodes.
Yes, right. So what we do is we, first of all, have a series of courses that we offer to our students and also faculty as well. Then we went through, we asked many of our teams that are interested in starting a company, let's say to commercialize a specific research finding, to come up to a competition. And this competition, it's a national gathering, and we have maybe a total of 30, perhaps, teams that come in, Andrea. And then these teams are trained on how to develop their idea. Have customer discovery is something that lasts for perhaps 6 weeks, and this is a partnership with the National Science Foundation. At the end of that, the teams that survive are then can take $50,000 and take this company and take it further to be commercialized.
Thank you.
Excuse me. 2 questions to you, sir. First is, could you tell me how many startups have you actually launched? That's the easy question.
Launched?
Launched by your school, by your college.
Companies, you mean?
How many startups?
Oh, okay, yes.
That's the easy question.
Okay.
The second question is, what is your view on the future of education? There was this very interesting view from Clay Christensen, which said that he really fears for the future of colleges due to the disruptions in education.
Right.
Could you speak a bit about
Sure,
that?
of course. So with respect to companies, startup companies, from the School of Engineering, for instance, the Startup Garage every year incubates about 10 companies. This is at the undergraduate level. From the MASI Entrepreneurship Prize competition, we have probably about 5 or 6 viable companies at the research level that come out. And you have to remember that this effort started in earnest the last 2 years. And so that's really what we do. With respect to the future of education, how much time we have? So the question is value added in a bricks and mortars situation. That's really what you're asking. Because, you know, you can definitely get information through the web at any given time. And so many of the things that we do in a campus environment has to emphasize skills in addition to to getting knowledge and information. And these skills, and the World Economic Forum actually have articulated them, involve things like creativity, leadership, persistence. These things that you can do by being involved with other colleagues, by mentoring, by having the faculty member act like a mentor rather than simply a person on the stage that simply throws information at you and you simply collect it. And so I think the universities are going to change in this direction in a very significant way. So outside the curriculum activities will become very, very important because they can emphasize these skills that I mentioned: leadership, perseverance, creativity, and also character. So these are things that we will make sure we will need to be able to have and change the relationship between the professor and the student. It will not be simply, it will be becoming more and more of a mentoring relationship than simply a relationship that it is based on simply the sage person to someone who does not have no information. I think this is happening more and more. Startup and innovation culture and all that emphasizes all these aspects, and I think fits naturally to this process as well.